Yeah, hello. Unfortunately, due to some more preparations than expected I had to do for the last talk, this is my only slide. And I want to go through, of course, these topics that we have here on the changes that, I mean, the Samba VFS has undergone significant changes in the last years. It all started with symlink races, and then Jeremy really getting freaked out about symbolic links, and all the changes that POSIX, or the new APIs that POSIX has given us to really live with the symlink races, or to work around symlink races. Okay, let's start by taking a look at connect.fn. So what is our virtual file system? Essentially, our virtual file system in Samba is our connection to the disk. And this goes back to, I believe, Samba 2.2. Alexander, you have done some very early work on this, right? Yeah. Back in 2000 something.
2001, 2002.
Yeah. And the goal is that you can, for example, if we look at one of these calls, open@, for example, this is very similar. I mean, it doesn't look very similar, but it has similar arguments as the Linux open@ system call. If we look at man open@, at least there's some resemblance. We have directory file descriptor, we have a path name, we have flags. Here we have a directory file system pointer, FSP that we call it. It's here. Oops, sorry, this. So we have a file descriptor for the directory, we have a path name, we hide some flags here and so on. This is kind of superfluous, but I mean, we intercept, we allow VFS module writers to extend Samba with functionality by intercepting these calls. This can all be chained, so you can have a VFS object that only intercepts a few calls and leaves everything else to other modules or even to the default module. This started out early 2000s as a wrapper around the normal POSIX system calls as they were there in early 2000. And this was open, this was unlinked, this was renamed, this was read and write. We didn't even have pread. For whoever knows what pread versus read is. So in the earliest versions of the VFS, we had to do a seek to go to a certain position in the file and then do a write. Now we have pread. So over time, we adapted the VFS operations that we implement, that we offer to intercept, to modern Linux, essentially, or modern POSIX, modern Unix. Then sometime later, we not only saw that intercepting pure VFS calls, virtual file system calls like open, read, write, unlink, close, and so on, but also higher level stuff. And this is done by Tim Potter back then from Isilon, when they wanted to implement additional functionality that goes far beyond what POSIX provides in their file system. So they have their Isilon, I believe it's called 1FS, which does know about higher level SMB semantics. And what they did is they added a essentially SMB level call that does have things like share access, which is the share mode a Windows client requests. So this pretty closely resembles what you can read on the internet when you say Windows Win32 create file API. Let's look what that does. Create file. So you can find, if you can read that, a share mode here, for example. And so Our VFS in Samba right now goes far beyond, really far beyond what POSIX provides. You can intercept this. So that was one of the evolutionary steps that we took to allow file system implementers to go whatever greater steps towards Windows compatibility somewhere. Okay. Just as an example, what modules do we have? And everybody having implemented a module. Our default module here is VFS_default. That's always default. For example, open@. This is what core Samba calls if you don't have any modules. So I want to open a file, and eventually we end up here. And if you look at what we get called here, the arguments here, this pretty much, this exactly resembles what was in this VFS.h, so the function pointer that you can intercept. And the core VFS, the core smbd calls this function through these function pointers. The very initial version of the VFS wasn't type safe. And so we made that type safe. So this is all being taken care of now. Okay. We had open. We just had the open call. And the open call, when you look at open@, we have the Linux open call. And we matched that with our VFS. And what does the open call as an argument take? It just takes a path name. And I mentioned symlink race condition attacks. What is that? You have /a/b/c/d. You check with something that you have access to /a/b/t/sli, and then you open this. This is the classic time of check, time of use race condition that we had to face, that you have a long path name and you check access. We have to do that in Samba for reasons I could talk about, but you have to check access separately from the actual open operation. So you check access to /a/b/c. A millisecond later you open it. In that millisecond, somebody has replaced /b with a symlink to /etc. And so this violates the guarantees that you believe having given to the client that you actually properly checked /a/b/c, which in fact you didn't, because when you then did the operation opening the file, somebody has moved you to /etc. And so etc shadow is kind of more vulnerable than you would have thought. This is why we, over time, and I'll get to what the recent changes are, we have moved more and more to the @-based calls. What is that? The @-based call takes a directory file descriptor. What is that? You can open /a/b, enter that directory, or not enter that directory, you get a file descriptor representing /a/b, and then you can open relative to that directory file descriptor. So what you do is you open /a/b, then you check access in that directory, and then you give this directory representation, which is this dir-fd here, and only give the the path name C to that call. So you know that you are stuck with /a/b. You have checked properly that you can access /a/b, and then you just open /c. Nobody else, even if somebody went in and set this /a/b, replace this with a symlink somewhere else, you don't care, because that's atomic. But you had a question? You just waved. Okay, or no, okay. Okay, so what we did is, if you look at our VFS, essentially, most of the calls that you find here that take a file name an SMB file name, will also take a dir-FSP. And then always hunting for calls that only have a file name and not a dir-FSP, and replace them with a call that takes a dir-FSP representing a directory, really with a proper Linux object and not a full path name. And yeah, we have changed most of the VFS, and I might have missed some, but we have like a few dozen calls here, and there might be some that we don't have. One of the calls, for example, that I want to replace is the stat call. What is the stat call? It just looks up meta information like when was the file last changed, how large is the file, who owns the file, and so on, the so-called stat information. That only takes a name. It doesn't take a file descriptor for the directory. And we are working hard towards replacing the stat call with the so-called fstat call, which is essentially the change from open/a/b/c, equivalent stat/a/b/c, to, okay, open/a/b, or yes, open/a/b, and then stat c relative to that. Because, I mean, once you have a handle on the directory and you have that dir-FSP here, all you have is a path name that does not have slashes anymore. And that's the important piece. Where I want to go eventually is never use slashes, never use multi-component path names in any of these calls anymore. Just to be sure that we will never risk any symlink traces. And the initial rush where we had this CVE with whatever, I think it was about make dir, that somebody could trick us to make dir something in /etc. That was the initial one that triggered all this. That was fixed, but I suspect we still have others there. I mean, one that we just recently properly fixed, I believe, is rename at. Come on, here. So we had these rename at thingies, but somewhere in our source code we didn't properly open the source and target directory. But I mean, this is the level of stuff you need to go through if you want to make that really safe, because I mean, this essentially takes a source name, a destination name, and the VFS hasn't changed, but the callers essentially gave this call a multi-component source name. It works, but it's not safe. And what I want to do eventually is, in every call that takes a name, we can do an assert, no, we don't want slashes here, so that we are not vulnerable to any symlink traces. Okay, that is my first bullet point here on the slide. We still do have symlinks. Of course, we have to deal with symbolic links in the file system. And if I say, okay, we want to be safe from symlink race attacks, what does it actually mean? I told you that, okay, you have /a/b/c, you check something, and the actual use of /a/b/c, somebody tricks you into B into somewhere else. How do you counter that? What we do is, and I want to show you the piece of code, file name convert dir-FSP. So give me a second. No symlink. Sorry, too many layers. Here we are. No, not yet. Here, that's the comment I was looking for. So, the SMB protocol always gives us long path names. So every time we open a handle, we get a long path name, and so on. We have to completely walk that directory path to the final path, to the final component. What we do is we split up the directory components into individual names. And what we say here, now we loop over all components, opening at each one, we get a directory handle. And then use that one for the next step as a directory FD. And when we open the directory, we can say, oh, no follow, which means, okay, if you find a symlink in /a/b, and b is a symlink, we get an error message. So, and when we now want to follow that symlink, we have this server follow symlinks equals yes, and this is the default behavior. If the user could have instructed us to follow these symlinks, what we now do, what we didn't do before, we relied on the system to follow the symlink. What we now do is we read the symlink in user space, and we check if the destination is within the share path that we exported. And where are we? So we hit a symlink in an atomic fashion, in a proper fashion. We read the symlink, subdir-off. Somewhere we have a check function that says, is the target symlink a subdirectory of the share that we exported? And we did have a bug in there in the first version, so we escaped some, but that's what it is. So the way we deal with symlinks now is we read symlinks and we evaluate whether that is safe to follow in user space. This means for a VFS implementer, you don't have to follow symlinks anymore. We do it for you. So if you have a VFS that implements everything like Ceph RGB or Ceph VFS, Ceph VFS or Gluster or whoever doesn't have to follow symlinks anymore. That's what we do for you. Alexander?
So I was just thinking that because you do the traverse of each individual component, it generates more file operations.
Yes.
And they all go through the VFS layer. So suppose you have multiple of those configured modules. Yeah. So does it mean that the overall operation is taken relatively longer in direct calls?
Thanks for the question. What we do is, if the file system supports the new openat2 call Linux provides, we do it.
Yeah, so we basically ask operating system to perform this for us if it supports it. If it not, then it's...
We have to do single step.
Yeah.
So for Ceph, for Gluster, for GPFS or whatever, I don't know if GPFS actually supports this, but we do the openat2 call with resolve no symlinks, which means we want an error message if there is any symlink within this /a/b/c whatever. And if there's a symlink, we do the single step again. But for the good case where there's no symlink, we get the fast operation.
Mm-hmm. And aside from Linux, who implements this? What BSD implements this?
No clue. I really don't know. I mean, FreeBSD is pretty well at following us. For example, what we need is essentially proc self-FD. That's what we need for good operations these days. I think FreeBSD has followed something similar, something equivalent. traditional like AIX or something, or maybe even GPFS doesn't have it, or CFFS via the libcfs doesn't do that, but it's really, really a very, very valuable speed up to implement.
Mm-hmm. So this one is a perfect example where the actual work on the storage side happens. It's
exactly
on Linux, not on the other systems, because they don't really implement this.
Exactly, yes. Okay, so we have our,
Did you ever consider a different type of protection against it, which is not opening the directories, but I don't know, so either like a range locking that during these, making it atomic, I mean the whole SMB request, which is a sequence of low-level file operations to make them kind of atomic, like that all of the range being traversed is now, it's impossible to rename anything in between, either with some kind of external table of locks or with flock on the directories. I mean, solve it in another way, kind of atomizing it.
We could do that if we had control over all access to the file system.
So you're saying
the problem is NFS and local access.
Okay, so it's not only the switch of the symbolic links, not only coming from SMB, it could be from somewhere else.
Exactly.
It's quite, okay. Yeah. Quite an elaborate attack, okay.
but it's what we have been blamed for, or what we have been attacked for. With.
I understand, yeah, of course. If it's not coming from SMB, it's...
And also, I mean, we used to have the operator, or with SMB1, POSIX extensions, you could create symlinks even via SMB. And so if we said, okay, well, this can only be safe when coming from SMB, we have this unsafe symlink something, unsafe SMB symlink creation. We have some operations that say, okay, either you accept white links, essentially being tricked into being referred to /etc, then you can do symlink operations via POSIX extensions, or you can't. But I mean, this is a deliberate choice if that you allow these kinds of races. And now we are pretty safe. We believe that we are pretty safe with SMB1 and SMB1 Unix extensions turned off, and only SMB2 being there.
Yeah. Okay. Thank you.
But the problem is local access.
Does this mean we can enable white links with SMB3 Unix extensions without any problems?
Yes, because with SMB3 Unix extensions, you can't create symlinks. You can create what looks to the client as a symlink,
yes,
but it won't be a symlink server side.
Got it. Okay, thank you.
Sorry, I'm just wondering if this is a generic issue that also kernel smbd has to address, this symlink race, or not?
To be honest, I don't know enough about KSMBD. But I mean, in theory, they are also vulnerable, but I don't know because I mean, in kernel, you have this NFS v3 style of lookup, single step. I don't know if they when they do security checks or these symlink follow, I don't know how they follow symlinks. And I don't know whether they rely on where is symlink resolution being handled in kernel? I don't know that. Is that above KSMBD? Is it below? No clue. Okay, another one. VFS chdir. Our VFS, given that we used to allow, yeah, go there. We used to allow full path names, which we don't anymore. these path names that we have given to the file system were always relative to the share root. And so there were also cases that we had to change. So what does it mean? A client connects to like 10 shares at a time and issues calls against share A, share B, share C. And so whenever we handle a call, we have to look, where are we in the file system? Currently, we have to change dir. We have to issue change current working directory to the new share that the client is requesting the next access for. This is costly, and I want to get rid of that. And we had like 10 or 15 calls in the core file system, somewhere back very far, where we also changed directory to not only the share root. And so this was a deeply rooted assumption that we could change dir everywhere. And I don't know if that's already upstream, but with all these changes to the add-based calls, sometime in the last few years, we figured out, okay, we don't have to have code to change dir into a subdirectory of a share, which makes a huge difference. And so like half a year ago or so, I tested an assert that, okay, we only changed to the share root. Why is it relevant? When we avoid the change dir call at all, and we have these dir-FSP calls somewhere around everywhere. So right now, the VFS assumptions that the guarantees that we give to the modules that Ceph and everybody else implements. We have given you the guarantee that we have changed directory to the share root. And I want to get rid of that because it's costly. It's a process global state. It prohibits full multi-threading or whatever. It's a process global state that I want to get rid of. So the first step is this deeply rooted assumption that we would need to change dir into a subdirectory. This is gone. We figured out we don't do that. So what we still do is, whenever we switch handling between shares on the same SMBD, on the same connection, we issue change dir calls, but we guarantee that we will only ever change to the share root of the share. And for people like Ceph, this, I would believe that makes a big difference, that you don't really have a file system, you don't have that global state, but we can now guarantee to you, if we issue a change dir call on a share, you can just ignore it. Because you have your handle to the root file system, or to the root of your share, and you'll be done with it. So you don't have to take care of changing to a subdirectory anymore, which I hope makes life easier for you. And I did rename the call to VFS change dir share root, just to make this obvious, that a fresh programmer looking at the code, we never issue change dir calls anymore that don't have the. So what I'm looking for now, what I'm searching is VFS change dir with open brackets. This should show no result anymore. Yeah, okay. That's just a comment. So there are no calls with a general VFS change dir call anymore, indicating to VFS implementers that they would have to implement whatever some complex state. Where are we in the share, within the share? No need anymore.
Is it somehow visible for normal local file systems? Is there any performance difference that we don't change the working?
I'm getting to that in the next. So I was looking at the vfs.h. So what I did, as I told you, I want to get rid of all path-based calls that do not take a directory handle. Stat is the one that is particularly nasty here. Why is it particularly nasty? All the VFS calls that we see here can safely assume that with some magic, all paths being sent here are relative to the share root. And the stat call is different. And I will show you why it's different. This call here. So make connection snum. This is being called very early in connection setup. We do share checks. Does the share root exist? Do we have an ACL and whatever? Does the share exist at all? Where does it point? Do we have a smbd.conf section for it? That's all done there. As part of that setup, we call this here. That's in that routine. And this one call will send an absolute path down to the directory, to the VFS. That is different from all other calls. All calls that we issue to the VFS take relative calls. They can safely assume that the whatever connection state to the VFS is properly set up. This call is bad. And it prevents some optimizations. And what I would like to replace it with, and this is what the reason why I wanted to talk to the VFS developers like the CEF developers or GPFS or whatever. I want to replace this one call with a new operation. And source 3, S3, so that's my latest development code. What? Here. What do I want to do? And this is essentially a real question. I want to replace this one stat call that is particularly ugly with open share root. And that's the main change that you alluded to. Right now, what we have is a connection relative root, CVD FSP, connection working directory FSP, that we hand down to the VFS whenever we don't have a proper FSP. Right now, when you go to here. So we issue the open-ed call. We don't have a proper directory open handle. What you can send down to the Linux file system is this special -100. That's defined as -100 somewhere in glibc.h. I want to get rid of this. And this AT_FD current working directory represents the current working directory of the process. What I want to do is, when opening the directory, I want a new VFS operation that is deliberately special, indicating in the VFS that it is special with open share root that says, do everything that the previous stat call in the old code did, namely check if it's there, have access or whatever, but also give me a proper handle of the share root. And then, when that's done, we can get rid of the chdir-Call. That's the idea. That we attach to the connection struct, we hold a proper handle to the share root directory. and then do everything based relative to this. And yeah, that's one of the more fundamental changes of the Samba VFS, that we don't give the guarantee. So what we would do is change dir to slash to the root of the file system at the very beginning of smbd process, so that we don't get into the way of somebody u-mounting whatever slash data by accident, because we just hold the directory. We will never hold any subdirectory as the current working directory blocking u-mounts of arbitrary file systems. We will change dir to slash. When we get a tree connect, when we get a share connection, we open the full path to the directory and hold a handle to that. And as long as the share connection is open, we keep that handle and do all operations relative to that. I mean, I have code for this now. Adding VFS operations is always a pain. It's like 2 hours of very, very tedious manual work going through all the VFS modules. But I got used to that now. But this would then allow us to never change directories anymore. And that's the main change I'm proposing here, and this is why I want the file system developers to be here. Okay. Then another little trick a customer actually asked me to do. So I have one customer who has a similar situation like CFFS. The situation is as follows: a very huge file system implementation, a clustered file system, all done in user space, and the normal access is via Fuse. They have the same problem as Ceph and Gluster. They provide a library, but this library is extremely heavyweight. And it's also license problematic. It's proprietary license. I mean, we allow VFS implementers to do whatever they want with some special exception, but it's always a hassle to talk that through lawyers. So for Ceph, that's not the problem. But Ceph and Gluster both have the problem that when you open libCephFS and open that with 1,000 or 10,000 processes on a host, each and every process just imports half of the Ceph cache, which is like gigabytes and gigabytes per process. Can't do that. So you have to funnel this through a proxy process. When we want to implement that proxy process, essentially we're in the business of implementing a remote file system. We could do NFS. We could do SMB. Or what we could do, and what I would like to do, is just run the Fuse protocol. With all the bells and whistles that the Fuse protocol has or doesn't have. And because, I mean, Bernd Schubert right now has done a lot of work to make Fuse faster with IOU-ring, with whatever shared memory mapping and so on. And I have a little prototype that where you can open or where you can run a Fuse process that doesn't listen for an I/O control to mount a file system, but that just opens a Unix domain socket. And what I have is a little, and I hope the customer name is not in there. No, it hasn't. I have a little Fuse module that only does 1 or 2 calls. I mean, it's far away from a complete implementation. I'm being asked to complete this. But essentially, this will, by hand, speak the Fuse protocol directly against a daemon that is sitting there. So what the Ceph proxy could do, or any other heavyweight Gluster something proxy could do, is open a Unix domain socket, listen to the Fuse, listen on that socket, and expect Fuse client. What you have to do is you have to serve 1,000 SMBDs simultaneously, but Samba will take care of whatever. You don't have to implement a VFS anymore. I have 5 minutes left.
Sorry, I afterwards. My taxi is already waiting.
Yeah.
So this is speaking to the Fuse device character device.
No, it's speaking to Unix domain socket at this point.
Okay, so it's not on top of that mounted POSIX like
Correct. But it's speaking. But it's. I mean, it's so.
Normal VFS default in this case. You don't need a fuse model because the fuse will be mounted.
Yeah, but it goes through the kernel and so on, and we want to avoid that round trip through the kernel.
I understand. Yeah.
Okay.
Yeah, I get it.
And then have potentially some additions to whatever mmap for whatever. To have some additions to the protocol to be able to mmap for accelerated file transfer or something. We want to avoid the kernel for this.
I will also say
Okay. And yeah, those are my ideas, my plans.
So basically, you would be bound to create something like fuse. And why create something like fuse if the fuse exists?
Exactly. Because I mean, whenever you want a Ceph proxy, what are you implementing? You're re-implementing NFS or whatever. I mean, or Fuse or 9P or I mean, there's a whole lot of local file systems or file system protocols. Just pick one that is very popular.
And that solves the problem community-wise as well, because if you're a commercial entity that doesn't want to contribute
Exactly.
the code, they still would contribute because instead of just enabling Samba, they will enable the whole Fuse community.
Exactly. And what I was pointed out by Bernd Schubert that you have this pass-through daemon that just mounts a local file system that's in libfuse examples. And it's trivial, and this is my code in this Fuse daemon now. It's trivial to change it from waiting on the Fuse character device. I don't even know what that is, to be honest. I don't know how exactly a Fuse file system is mounted. What I do know is that it takes requests from the kernel over some mechanism, I think a Unix domain socket. And it's trivial to change this to create a socket, not listen on the Fuse device to wait for a mount request, but just serve a Unix domain socket. And this is something that I can sell to all proprietary file system vendors. If you give us that with a defined protocol, you have a Fuse anyway. It's slow, it sucks, and we would be happy to be a client for your implementation via this mechanism. 2 minutes.
Sorry to interrupt, but it's a coffee break coming up, so
Okay.
if you want to have the half hour, you could go on.
But as I said, I mean, this is my only slide. I don't even have a question slide.
But the other benefit out of it is because it's a Unix domain socket, you benefit from getting from the kernel all these security properties, like the SLinux, like the finding out the other contexts. So you can now influence what the other operating system will see under constraints.
That's a different topic.
It's important part.
I mean,
because
it's one
now
of the other, yes, but we have changed the current working directory, global state. We have per thread credentials, whatever, global state. And how we deal with that, I mean, we have a chance now. But this is not really fully fleshed out. I know about the problem, but this is something how we properly transmit the user credentials used for this particular request. Open question, I don't know yet.
But what I'm trying to say is that it opens a possibility for us to solve that problem.
Of course, without doing the setUID calls,
Yep.
which are very expensive.
Yep.
Of course, yes.
So from libsfs side, for example,
I can hear you through the...
what needs to be done? I mean, what is expected from libsfs? I mean, we do currently have a fuse. We can do a fuse mount, but I'm not sure whether it is using libsfs or not. But what's the expectation here from the libsfs side? Suppose we have this fuse VFS module. what's the next step that we need to do to leverage this mechanism?
So the next step would be, I mean, in concrete terms, transport. I think it's called transport. No, it isn't. IO, here, set custom IO. That's the one. Right now, libs FFS has a fuse daemon. I mean, you have a kernel implementation, but you can also, I hope you can also mount via a fuse daemon. Yes. This fuse daemon calls some fuse start, fuse mount, whatever, fuser mount, whatever. And this then implicitly creates an IO structure for you that sends you requests that go essentially via here, these calls, these low-level ops. So the Fuse library calls these operations. And all the I/O is being done behind your back. You don't know about this. The change I'm requesting is that you make it this explicit, that you don't rely on libfuse and the fuser mount call to set up all this mechanics of getting requests from the kernel, calling this one here, and sending back a result to the kernel. But instead, on your own, listen on a Unix domain socket, take clients, and then go through libfuse and have libfuse call this here. But so the pure transport kernel to libfuse is being replaced by you explicitly listen on a Unix domain socket, you read our requests. That's the only change. It should be like 200 lines, 500 lines, not more.
Okay.
Does it answer your question? Did I get you right?
Yeah. We'll wait for we'll wait for the final version and we'll.
Okay.
Thank you. One small question. If we have some multi-component paths, and before this changes, and it contains two symlinks. One will take us out of the share, but later another symlink takes us back to the share. With the original implementation, that will pass because we will rely on the OS.
Yeah.
But now we will just stop it at the first symlink.
Correct.
Oh, okay.
Yeah. That's correct. I mean, that is a change in behavior that I didn't expect. But yes, it's there. Yes.
What doesn't matter?
Yeah, but you're right. We do it step by step, and because we don't rely on somebody else having us jump back, but we do it step by step, and at each step, check, yeah, you will be blocked. But nobody has complained. And this is out like two versions ago or something, or 3 versions ago. Daniel.
Also, one question about the symlink issues that you tried to cover here. Have you also explored the option to go a route similar to what NFS did and just supply the smbd processes with a sort of a synthesized mount namespace that only sees the part of the shares that are actually exported for this specific tree connect?
No, we haven't. Yeah, mainly because I just learned from you that this exists. And I mean, all this open. So we right now we still have the fallback to run on AIX in the same way. And yes, of course, we could always utilize latest Linux versions. I mean, this might be old. So I don't know. But yes, we could, of course, improve there. Yes, and make things safer and simpler. But remember, we have to switch between shares all the time. So we would have to have a per share, whatever fake mount. As I said, I don't know that mechanism. I don't know how it exactly works. But essentially, this is what our share root file descriptor should be for. This is our way to go there. We can't fully confine a process to a share root because the next request will be for another share. And this will change potentially with each and every single SMB request. So what we will have to do is a file descriptor handle on that protected subdirectory or that protected mount or whatever. But then we can also go with the file descriptor on the root directory. So, summary, I need to learn about that mechanism. Whether this benefits our case. I don't know, I just don't know.
Do you have any more topics?
No. End of slides.